we've been able to attract people from companies like Electric Boat, from companies like Raytheon, and not because we offer more money or offer better benefits, but they can have a key role to play in some missions, some exciting upcoming missions that they'll be able to tell their grandchildren about. So it's, I think, that kind of exciting application they can work on right now that is an attraction for them.
Just a quick reminder for you to like, subscribe, and rate this podcast so we can get your feedback and know how to make it better.
Hey, it's Ari. Welcome to another episode of the Made in America podcast. Today, I'm with Bill Smith, President and CEO of Infinity Fuel Cell and Hydrogen. Bill, thanks so much for coming on today.
Well, thank you for this opportunity to speak with you.
I mean, I'm looking forward to it. But before we get into the details, we got to start with the Made in America podcast questions, Bill.
Okay.
What do you make and why do you make it?
We make fuel cells and electrolyzers. And the fuel cells generate electricity from a reaction of hydrogen and oxygen, and the electrolyzers generate hydrogen and oxygen by application of electricity. They do the reverse reaction.
Gotcha. All right. And why do we do it, Bill?
Well, it depends on the application. In the fuel cells that we have been developing, we've been primarily developing them for NASA and for underwater applications funded by the Navy primarily. And there, NASA has found that fuel cells trade off better than other ways of making electricity, especially for manned missions. For manned missions, we can run off of hydrogen and oxygen from the propulsion systems on a rocket and make electricity and water from that. And you get power from the fuels you already have on board, and you get water that the astronauts can drink. And that has been the way of providing power on manned missions ever since the Gemini program through the shuttle missions. But the shuttle was retired and those generations of fuel cells were retired, and NASA selected us to start developing the next generation.
Is the same issue underwater too, looking to be able to generate water for people to drink and power at the same time?
Not so much generating the water, but it's generating the power at the same time, because underwater you have basically the same problem. You have to have air-independent power systems. And fuel cells combined with hydrogen and oxygen storage can provide you with more energy storage so you can do longer and longer missions. You can do much longer missions that you could do on battery alone. And the only other thing really better that for long missions would be nuclear. And for the types of missions that the Navy is looking at for small vehicles, nuclear is really not an option.
So air independent?
Air independent.
What does that mean?
Means going where there's no air.
So
outer space and underwater, and that's primarily what it means.
And what's the importance of having to have a solution, a non-air solution to generate power? Because the other ways we do it through combustion require some type of air to combust.
Because they need air, exactly. Or you need something like batteries.
Gotcha, right. So so on the manned missions, we're looking at the electricity, not the propulsion of the ship,
right,
but just the electricity on the ship. Is that also true in the underwater applications?
Now, underwater, it's looking at propulsion and powering the electronics.
Okay, and why? When I'm in a space mission, why not? Like, why is this? Why is the segmentation, right? Like, why am I only in outer space? Why would I only use a fuel cell for power and not for propulsion?
Well, because the propulsion type of systems that you need in space are, reaction type systems. You need a rocket, basically.
Right.
If you're flying an aircraft, of course, you have air, and you can use air and, heating up the air and then blowing it out the back of a jet engine for propulsion. In space, you can't do that. So you bring along your own oxidizer, your own fuel, and you make your propulsion that way.
And then using the fuel cells for the electricity in the water. Okay, so I definitely want to get into some of this. We'll want to talk about sort of fuel cells and the direction it's going. But I also want to start off maybe a little bit with a deeper why, which is, why are you doing it? How'd you get into this business? Like, what kind of powers you?
I got into this business. I used to work at United Technologies Hamilton Standard back in the day. Now it's called Collins Division of Raytheon Technologies. And I got involved in it there right after Hamilton Standard had bought the business from General Electric in 1984. And I was already working at Hamilton Standard, and I saw the option to go work in this business, which was working in space type systems. And so I elected to do that. And I was really taken with the elegance of the whole process, the whole reaction. You take pure oxygen, pure hydrogen, and you make electricity, and you do it without creating any hazardous hydrocarbons or emissions, carbon dioxide, anything else. It was just very clean, elegant chemistry. Devilishly hard to make work, but when it does, it's beautiful. Beautiful, clean, and efficient. So I was taken with the chemistry then, and then got more and more involved with the engineering challenges and the missions as time went on at Hamilton, and so on. In a little bit of my story too, I worked in this business where we were making fuel cells and electrolyzers at Hamilton until 1996, and then myself and 3 other people from Hamilton split off and founded our own company at that time called Proton Energy Systems. And we located that in Rocky Hill and eventually in Wallingford, Connecticut. And that was aimed at making water electrolyzers for commercial markets. And we were successful in doing that. We took it public on the NASDAQ in 2000. And still Proton exists as a subsidiary now of a larger electrolyzer company called NEL in Wallingford, and I think employs about 100 people right now. Oh, wow. So it was kind of that journey with this kind of elegant chemistry that you could just see have application to space, underwater, and then eventually helping with climate change throughout the world. And I was attracted to that and been fortunate enough to been able to work in it.
So we go through the Proton Energy experience. When did you leave Proton?
I left Proton in 2002. At the time, Proton was headed in more of an industrial direction. They wanted to make electrolyzers for good old-fashioned industrial purposes where hydrogen is commonly used. And I wanted to work in this area, more on fuel cells for aerospace, and it just wasn't the direction the company was choosing to go to at the time. So I left to focus on what I'm doing now.
What you're doing now, now I know this is a little bit off the top, but I'm just curious. Industrial uses a lot of hydrogen and then wants to look to make water?
No, industrial uses hydrogen for many, many different processes. Hydrogen is used in powdered metal manufacturing. Hydrogen is used, oddly enough, for generator cooling in large, power generation plants because it reduces the resistance of air when you're spinning a big generator. You spin your big generator in a hydrogen environment, and it's more efficient. It's used for hydrogenation of oils. It's used for even enhancing gasoline. And a lot of that is made by other means, but it's not made by water electrolysis. But hydrogen is a very widely used industrial chemical.
And so the idea would be that there's an electrolysis device that takes water and then breaks it into components, parts, and then you can use that hydrogen in industrial applications.
And then you don't have to have a big inventory of hydrogen bottles or tankers or anything like that. You just have water and electricity, and you have all the hydrogen you need.
You sort of just make it on demand,
make
essentially.
It on demand. Right.
And water's pretty stable and relatively easy to find, as it turns out.
Relatively easy to find, yep.
So your passion was just not really in that part of the business and more to do with the actual application of power generation.
Yeah.
Or electricity generation. And so then what happens? So you decided to leave Proton and then you found Infinity, or what happened? How did that?
Yeah, I left Proton in 2002 and was fortunate enough to be able to be funded by NASA shortly afterwards. So, I was able to build the relationships or extend the relationships I already had in that community and get funding by NASA to bring some of these ideas forward. So we basically bootstrapped right from there. I self-funded that initially, and then have been funded by, some combination of government and commercial ever since.
And when you went in this direction, why NASA? Why military application? Why go that direction and try and get it funded?
Because that was where the need was. As I mentioned earlier, there's some applications like manned spaceflight where the fuel cell is not there because it's cheaper, not there for some other reason, but it's there because it's the best way to accomplish the mission. And NASA at that time was retiring the orbiter fuel cells and looking for new options, and our technology fit in very well.
Traditional supply and demand, sort of the basics. So let's talk a little bit about the technology, and we did a little bit earlier, but just let's get it back to it. And for the people that are watching on YouTube, there's something on the desk here, the table here. For those of you that are listening, as I typically do, I don't really even know how to describe it. It's like a cylinder. It's actually quite small. Maybe Bill, you could more aptly describe it, and then sort of tell us what it is.
I'll try. First of all, looking at the basic reaction. What we do is the chemistry that we do is we take in hydrogen and oxygen and combine the two to make electricity, water, and waste heat. And we do that in this device across a material called a proton exchange membrane. It's a something that looks like a piece of Teflon, but it has sulfonic acid groups attached to it, so it functions like battery acid. So you imagine battery acid that's safe to the touch, and it's inert. So that becomes your electrolyte, your membrane electrode assembly, where you can conduct this hydrogen-oxygen reaction. And what it looks like inside of that cell is just a flat sheet that's about 10 mils thick. And we arrange that between bipolar plates that actually bring the hydrogen in, bring the oxygen in, and remove the water and or provide coolant to the system as well. And those plates, metal plates, are about 1/10 of an inch thick. So you have a 1/10 of an inch thick metal plate, an electrolyte, and then another metal plate, another electrolyte, and you stack them up in a filter press arrangement, and you have a fuel cell stack. And so that's basically what you have sitting here on the table. It's a stack of these bipolar plates and membrane electrode assemblies between end plates, and you provide reactants to that, hydrogen and oxygen to that, and you get electricity and your product water out of it.
And so what would something like this be used in, this exact assembly here?
Something like that, and a small one like that, maybe a little bit larger, could be used. In fact, NASA has funded us to develop a version of this that can be used on the surface of the moon to provide power throughout the 300+ hour long lunar night. And it's a big deal.
It's a long night.
It's a long night.
300-hour night, that's a long night.
300-hour night, and it gets down to about minus 280 degrees Fahrenheit. And if you try to do that with anything besides nuclear, if you try to do that with batteries, you find that the amount of batteries, the number of batteries, the mass of the batteries to do that is far greater than to doing it with a fuel cell and hydrogen and oxygen.
And I mean, this might be very technical of a question, but how much power or whatever what does something like this size actually power? I don't kind of...
Something on that, the one we're doing for NASA is basically the same size, but about 4 inches higher, and provide about 1 kilowatt of power.
And kilowatt of power, and then how much fuel do you need? Like you put water through it? I'm trying to figure.
No, you put in hydrogen and oxygen.
Right, and then that makes the water.
It's like your car. Okay. That is the engine, and the hydrogen and oxygen tanks are your gas tank.
Right, and that's where you get the H2O
put in
on the
the
other
size
side.
of tanks that you need. That's all. You just make that gas tank just what you need for that mission. Now, what NASA is doing is not only the fuel cell on the moon, but they're doing the reverse reaction as well, so that you have a 300+ hour long lunar night and you have a 300-hour lunar day. So during the daytime, you're taking that water that you make from that reaction and you're electrolyzing it again to make your hydrogen and oxygen.
Using solar power? Is that why?
Solar power. So basically, the combination becomes a water battery, and it can work throughout those long lunar days and long lunar nights.
That's amazing.
Yeah.
It's probably some cool, fun stuff to do, yeah?
It is. Like you see the moon rising and you say, oh, wow, that's where we have to make these systems work. And that's a challenge that just is exciting to meet.
So do you need to simulate, like when you're thinking about putting someone out on the moon and they need to survive 300 hours on this battery, where are you testing that? Do you set up, so you just test it here?
We do some of the testing right here in Windsor. NASA has set up labs where we're going to be delivering these systems to them, and they're going to be putting it through those extended tests. They're also putting it through shock and vibration, thermal vacuum tests, and other EMI and other tests that are relevant to that environment. So it's a combination of our testing and then NASA testing.
It's unbelievable. And we talked about sort of the space component, and then the underwater component is you said small vehicles, and it is propulsion underwater?
Yeah, primarily for propulsion underwater, but it also powers any of the instrumentation that you have on board as well, because these are aimed at various different missions that the Navy has, primarily the Navy, but can also be used for commercial as well.
How many folks do you have in Windsor putting this stuff together?
Right now, we have a little over 30 people, and in another 2 weeks, we might have a little over 40 people.
Wow, that's a substantial growth.
We have a number of job openings, and I have 3 people starting on Monday. So
So what's sort of, speaking of powering, what's powering that growth? Kind of what's behind the...
Well, what's powering our growth right now, in addition to our government contracts, are, believe it or not, commercial space programs. We have 2 large commercial space contracts that we've just entered into this year for both fuel cells and electrolysis systems. And that is driving a lot of what we're doing right now. So a lot of the things that you read about in the newspaper when you see some of the largest names that you know are funding our developments in these areas. And in fact, one of the things that we're doing is we're actually flying a fuel cell test article aboard a New Shepard launch vehicle in August. And that program is primarily funded by NASA, but it's flying aboard a Blue Origin New Shepard vehicle, the same vehicle that you saw William Shatner fly up in, a few months ago.
So you're trying to add a lot of people, certainly relative to the size of the company. Is there some specialized folks? Like, how are you trying? What are these roles that you're filling, and how are you finding folks to fill it?
We're filling all kinds of roles. From administrative roles, we have, for instance, a new controller starting on Monday. We've been staffing up a lot in our engineering area, mechanical engineers, electrical engineers, systems engineers. We'll be hiring electrochemical engineers as well. So kind of across the board. Quality systems.
And what's sort of the attraction? What do you do to try and get them? Look, you're not the only one that's out there looking for engineers. What's your sort of strategy to say, hey, we could do something here you can't do somewhere else?
Yeah. I think probably the biggest thing is our missions, where we're going, what we're doing. We've been able to attract people from companies like Electric Boat, from companies like Raytheon, and not because we offer more money or offer better benefits, but they can have a key role to play in some missions, some exciting upcoming missions that they'll be able to tell their grandchildren about. So it's, I think, that kind of exciting application they can work on right now that is an attraction for them.
Going back to the old Hamilton days, sort of I used to work on the spacesuit that you saw on TV type of a story?
It's real. It is real. When I was at Hamilton, I was impressed because when like in Apollo 13, you got that phone call in the middle of the night. I know those people that got that phone call. It's exciting. I myself worked earlier before Hamilton at a company called PerkinElmer out by Danbury, and I worked on the Hubble Space Telescope program. And I only, one of thousands of engineers working on that, but it was something you look back on and you say, that you had a little small role to play on that, and you remember the mirrors being ground, being part of that. So it's an intangible, but it's something that gets people going.
Absolutely. I mean, talk about people wanting to put in time to be behind like a real mission and be a part of something. I guess they have that opportunity, and not to be at infinity, not to be one of thousands, but to be one of dozens.
Right.
So
you have a real impact in growing the company. Yeah.
Yeah, that's pretty cool. So I want to talk about just sort of the fuel cell industry in general. Maybe take a little turn to that for a few moments. It's been something that's been talked about for a long time. Obviously, we talked about it was on the Gemini program, the Apollo program. Right. So fuel cells have been around for a long time. And I've been around long enough and in Connecticut long enough to have heard about the promise of fuel cells, and hydrogen power transforming the economy many times. But it doesn't ever seem like it gets the promise that we hear about. And I wonder your thoughts around that and if that might be changing.
I think it is changing. And I think that the ultimate reason is that if there's a better way to do a job, a more cost-effective way to do a job besides using a fuel cell, people will do it. They have done it. So that is, while fuel cells 20 years ago or 30 years ago look like an attractive technical solution, and they are, if they're not cost-effective, people are going to have to use the more cost-effective solution. For our missions, this becomes the most cost-effective solution. We trade better than other trades for NASA. We trade better than other trades for underwater. But for the wider society, there's been other options. What's happening now is that kind of what happened with wind and solar in the 2000s and 2010s is you're seeing the cost of this technology come down, and you're seeing the cost of competing technologies go up, and then other things happening that are global events that are contributing as well. So right now, for instance, a company called Plug Power has found a niche in material handling equipment where it is more cost effective to use their hydrogen fuel cells than it is to use battery or propane power systems for forklifts. Now, that may sound like a niche market, but then you look at Amazon, Walmart, and others have switching over to their products, and they're making thousands and thousands of systems. Now, that's still not going to replace your automobile right now, but there's other steps that are being taken, other companies that are being developed to work on, say, fuel cells for heavy-duty trucks. And then as the cost of maintaining and meeting emission standards for diesel-powered trucks goes up and up and up, and diesel prices go up and up and up, it's getting more cost competitive to power large trucks and other large heavy-duty vehicles using hydrogen and fuel cells, so that the world is changing out there. And then kind of on a larger scale, when you look at overall energy use, climate change, and so on, what is becoming very interesting right now is the low cost of renewables. The raw material going into the electrolysis process now, where you decompose water to hydrogen and oxygen, the raw material there really is electricity. And that
Hold on
electricity.
one second, just want to make sure I get this, clarify on this point. So what we're saying is how do we get the hydrogen that powers a hydrogen fuel cell?
Right.
And the easiest way, best way to get it, take water or the cleanest way to get it, and use the electrolysis process, which some of us maybe remember from high school or grade school, right?
Where take this, water like this.
Yeah, and then all of a sudden your teacher shows you can light it on fire or whatever. Okay, so that's the idea. Go ahead. Yep.
But what's happening out there in that broad scale is the cost of that renewable electricity is coming down. The cost of competing alternatives like natural gas and hydrocarbons is going up, and you're seeing that crossover occur. And as you look forward, 10, 20, 30 years, you can see where there's a good pathway to hydrogen generated by water electrolysis using renewable energy to replace hydrogen in many, many uses, from ammonia generation to many other chemical systems to directly use in fuel cells. And so that there's a pathway to have using green hydrogen to help with the climate change solution long term. So things can be pretty good long term using that pathway.
Let me back up before we go forward again, because I think I do want to. One of the notes I did have I want to talk about is the long term play for climate change and maybe getting into that a little bit. But I just want to go back for a second. So we think the business model for fuel cells has been challenged because the price of competition has just been too low.
Yeah.
And so the idea is that now that the price of the competition is going up and the price of the fuel cell is going down.
Mm-hmm. Correct.
So what's driving? I'm going to take those in two parts. Mm-hmm. What's driving the reduction in the cost of the fuel cell creation?
It really is scale up and mass production for many of these applications. For instance, companies like 3M now are routinely making large amounts of the membrane that I talked about in there. So those mass production processes, given the initial niche applications like forklift manufacturing, are helping to productionize many of the things that go into this building these types of fuel cells.
So if I could just maybe basic that up for somebody, that idea is if we're making more of them, the cost is going to come down.
Cost comes down.
So as the use goes up, so it's sort of a funny chicken and egg situation, right? You kind of need people to use lots of them, so the production's high to drive the cost down, but you need the cost to be low enough for people to be able to use. So there's a little. And do you think that we've crossed over some Rubicon in the chicken and egg scenario with some of these industrial applications?
Maybe we have a pontoon bridge that we're starting to use.
Okay,
it's getting there. It's getting there.
Well, you got to start with a pontoon bridge. Everything's got to start somewhere.
That's what these niche products are doing.
And do you see the use in those? I'll call them, I don't know if specialty, but I'm going to call them specialty applications, i.e., the use in space missions and underwater missions. Are those growing at the same time? Meaning maybe the mass use is growing and the specialty needs are also growing simultaneously. So we're getting some type of a push there. Or?
Oddly enough, they are, and just because of you see the growth in commercial space. You see what SpaceX is doing, what Blue Origin is doing. So you have these individuals that have the resources to do this just because maybe they want to. That is right now driving a revolution for us in these types of applications. Now, NASA by themselves probably wouldn't have done it. But now this combination is actually making a lot of this happen in these markets, even in the space and underwater markets.
Do you? I mean, now I'm going to take a left turn and come back. But
Okay.
do you? And I don't know if you have a view on this, but do you think that regular low orbit space flight is going to become more and more common? I mean, obviously we've seen the big splashes with, you mentioned William Shatner and,
Right.
and obviously the, the tech guys who are doing their stuff. But do you think that it's going to be something that over time in the not too distant future is going to be like air travel where people will do this affordably?
If in the near term, affordably, no way. It's just too expensive. But there are for us meaningful advances happening there. As you probably have heard, that there's a goal to probably deorbit the International Space Station sometime in the coming decades. And what NASA is doing is they're evolving a whole industry of private space stations, commercially developed space stations, to replace that. And they will be lower cost to access, lower cost to use, and lower cost to launch. And we're working with that community as well. And what's interesting there is, in that case, not so much the fuel cell aspect, but the reverse reaction, the electrolysis aspect. Electrolysis today is used aboard the ISS, the space station, to make life support oxygen for the astronauts. It's also used underwater, but it's not our electrolyzers in that case, but it's been used underwater since the 1950s for nuclear submarines. But that's how oxygen for life support is made for submarines and for outer space.
Oh, well, that makes a ton of sense, right? You got the nuclear power,
Right.
use that to power the electrolysis. You got water everywhere, and
Right.
so right. Although generally you want to keep the water out of the ship, but I got you.
Right.
Yeah.
You bring some in to use it.
Right, I got you. Okay, that makes a lot of sense.
So that for this new generation of private space stations, they have the same need to make oxygen. So whether you like batteries or fuel cells, you still
let
need,
me ask
need
a
to
question on
breathe.
that. You're suggesting that in our lifetime there'll be like multiple private space stations?
Yes. They're starting to launch in 2024.
Really?
Yeah. A company we're working with, Axiom Space, they have contracts with NASA right now aimed at launching as early as 2024.
I see, like in my mind's eye, I see like the Jeffersons with like billboards up there. And so this idea is there will be private stations that are doing what the ISS is doing now, just up there doing like experimentation, and they'll rent. Then the funding comes from renting out the space to governmental space agencies.
I suppose that's their marketing plan, from individuals to companies to other governments, but it'll provide capabilities very similar to the ISS, but in a privately funded way.
So I said I was going to take a left turn and come back. So here's me coming back. So the market has shifted. We certainly, anyone who's driving a car knows the cost of
Right.
petrochemical fuels is going way up. But I wonder this, which is, this isn't the first time we've seen a massive increase in gas prices. And all the talk about renewables and everything else, only to be followed by a massive crash in gas prices that drop down back to levels, and then all of a sudden,
Right.
People are back buying 8 miles a gallon, or maybe 8 gallons a mile, trucks. So why would this time be different?
Well, what's happening right now is really not driven by the price of gasoline. This was happening when gasoline was $2 and $3 a gallon, and it was starting to change because of other forces at work out there in the world on the large scale. I mean, our segments are entirely separate from price of gasoline and these terrestrial factors. But the larger market that you're talking about, that's being driven by these much larger global trends. If you want to help solve climate change and the rising cost of natural gas, not driven by these immediate spikes, but driven by this longer term trend, and then on top of it, what we've seen just over the past few months has been driven by geopolitical trends. Europe, the European agency, EU, and Germany are funding a new program to the tune of hundreds of billions of euros to develop alternatives to Russian natural gas. So that you have some trends that are outside of the normal economic trend that are also driving these alternatives. Because you can use hydrogen and that you can generate by clean electrolysis and carbon dioxide that you can remove from the air, remove from any other processes to make synthetic natural gas and feed that into the pipelines. You can feed some percentage of hydrogen directly into natural gas pipelines. So you see some of these political issues that are now having a real economic impact to the tune of hundreds of billions of dollars to fund alternatives to sources of gas from places like Russia.
So I think we're taking this to another place, but I'm going to follow this thread because I think it's really interesting. So, I mean, you've just taken a turn to say that the same sort of technology and processes that are used in fuel cells could be used to solve much bigger problems. Yes. So let's sort of talk about that. I know you have a view on sort of a very positive, uplifting view on sort of climate change and the future. So maybe I'll let you sort of start laying that out, and then we'll talk about it.
Well, sure. When I look at this, when I look at the possibility of hydrogen generated by renewables and water, or what they call green hydrogen, and the fact that it can economically be used for uses from transportation, ground transportation, even aircraft transportation, but also for many, many other important uses, such as developing ammonia for eventual fertilizer development and other chemical processes, steel manufacturing. There's a pathway there to I think a pretty optimistic future in being able to replace fossil fuels in many, many, many of the different applications that it's used in right now, and to get climate change under control. So if you look ahead, probably decades at this point, but if you look ahead in the coming decades, hydrogen made by clean electrolysis can help solve climate change. So it won't be the whole solution, but it'll be an important solution. So things can be okay. Things can be okay as long as we don't blow ourselves up. Things can be okay.
Well, let's park that one negative concept for now, because you have me really smiling for a second there. Don't get me down the other thing, right? Because sometimes it feels like we're really close to doing that. But
I think things can be okay.
Yeah. So so I just want to pull back, because I mean clearly you're very smart. So and I just want to make sure I'm following along and maybe help other people who are following along. So the idea is clean. Let's just break it into component parts. So clean electrolysis would be, if I'm put all together what we talked about before, using sort of, I'll call it green energy, wind or solar, right? So totally renewable to power the electrolysis that could take water and break it into component parts, hydrogen and oxygen.
Exactly.
So I think a lot of us have an idea what we could use oxygen for, breathing, but also for combustion, and you could lots of medical stuff, tons, right? Okay, so that's helpful. And then the hydrogen, you said something about synthetic natural gas. So I don't know if this is the case, but the thought process in my mind, hydrogen could then be replacing natural gas to be used in power generation. Is that how you make synthetic natural gas?
You can make synthetic natural gas by a variety of processes, but the primary one is called a Sabatier reaction. So
I'm following. Go ahead.
you take your hydrogen and you take carbon dioxide and you basically make synthetic methane, and methane is basically natural gas.
Okay, and so if we're turning all of our water into its component parts, does that become a problem? If we're just using billions of gallons of water to break into hydrogen and oxygen, is that a problem?
Well, if you're using it in a hydrogen fuel cell, you get all that water back. So you get it all back.
Right.
And even if you're
totally recycling.
Yeah. If you're using it in a combustion process, you get some of it. You get some of it back. But
so we've got these ideas to be able to solve the natural gas problem. Like, kind of walk me through how does this get actualized? How does it happen? You're saying we have a path to solving the climate change process. Like, how does that happen?
Well, what's interesting right now that I've seen, and we've been, we're not involved in that in a heavy way right now. We do see that we'd like to bring some of our technologies down to earth and be part of that solution. We are very, very, very familiar with the types of electrolyzers you need to make large-scale systems. But one of the most interesting things I've seen very recently has been kind of the financialization of this. One of the things holding back all of this industry has been who's going to pay for things. Mm-hmm. And what I've seen on some of these very, very large projects that are either have just been signed or about to be signed, you're having the major global banks and other financial sources fund the consortiums that are putting together basically gigawatt scale electrolysis systems that are using gigawatts of renewable energy to make the large amounts of hydrogen needed to make large amounts of ammonia in locations like the Middle East that can then be exported around the world. So that I'm seeing this financialization process happening that never happened before, where people now can look at this and they're saying, you know what, when you pencil in the economics, it's working out compared to the alternatives. So again, like I said,
And that's the underlying difference.
that's the underlying difference.
That was not true before.
Not true before. And that's always been true of the problem of fuel cells and hydrogen, that it hasn't been the most economic solution. Now it's starting to get there. And I'm starting to see big banks and big financial institutions signing on. That never happened before.
And where does Infinity's technology fit into the larger landscape?
Yeah, what we are looking at doing right now is taking some of the advantages that we, quite frankly, have been developing for NASA and the Navy, because technologies that can make things smaller and lighter and more efficient have a role to play, and then scaling them up for some of these large applications. But we're not the first one to that. My old company actually is involved in that quite a bit, Proton, as part of NEL. So we're not the first to come to that, to that competition, but we think that we have a role to play in it, especially in like high pressure hydrogen generation. Believe it or not, we can make hydrogen at 2,000 PSI and higher without any mechanical compression. We do it all electrochemically inside of that stack. In fact, that stack design right there, we've also used as a 2,000 PSI electrolysis stack. You can do that by simply, as you make your hydrogen or make your oxygen, you close the outlet valves and regulate that to the pressure you want, and you'll continue pumping those protons across the reaction up until it gets to that pressure. So it's quiet, efficient electrochemical compressors can be a role that we can play, or the generation of hydrogen directly at pressure. So, we can be our company right now does see a pathway to bring some of those NASA technologies down to earth to play an important role in the green hydrogen solution.
Bill, listen, I've followed almost everything we've talked about, but here's the thing I'm going to say that I've taken away. I am just really happy that there's people as smart as you and your team working on solving these problems, because they are big problems. And whether it's, putting people on the moon or dealing with the long-term environmental future, it's cool that there's people that understand this level of technology, because it is going to take great technology to do great things. And it's the same technology that, put us on the moon in the first place. It's going to have to help us solve the problems we have here down on Earth. So kudos to you and your team.
Thank you.
It's awesome. And glad you guys are here in Connecticut doing it and looking for folks.
Yeah. Thank you.
I'm going to convert us to our rapid fire round of questions. Are you ready?
No.
Yeah. Oh, you'll buckle up then, Bill, because we're going anyway.
Okay.
All right. You ready?
Sure.
Red Sox or Yankees?
Red Sox.
Nice. Starbucks or Dunkin'?
Dunkin'.
Staycation or exotic destination?
COVID, it's been staycation, exotic. I want to go there.
There you go.
There again.
iPhone or Android?
iPhone.
Sports car or SUV?
Right now, SUV. I use it for work.
For work. Do you have a favorite business book?
No,
Okay.
I don't. I've read so many of them in the past, but I don't. I wouldn't point to one as a favorite. What I do see is I look back and wonder how they apply today. But no, I don't.
Yeah, got to use that. Got to use that history. If you had to do something, Bill, other than be the president and CEO of Infinity, it could be anything in the whole world, what would you do?
Oh, anything.
Anything.
God, I don't know. For a career?
Yeah.
I don't know. I might be a writer. Yeah.
Fiction, nonfiction?
Fiction.
Oh, very nice. Good stuff. What's something, Bill, that you learned early in your life or early in your career that you think's helped propel you to all the success that you've had?
Oh, I think kind of the most important thing was how necessary it was to find something that I really wanted to do. Not just for a paycheck, but something that inspired me. And in both, when I was working on the Hubble and working on these other programs, that sustains you. You can get a paycheck many different places, but something that was really inspiring to work on, I found really, really helped pull me along.
I don't often do follow-ups on these rapid fire, but I am going to do a follow-up right now. What did you consciously look for something, or did it just sort of stumble into your path?
I don't think I consciously did, but I was always there. It wasn't like I said, I need to go out and get inspired. It was like I was drawn to these things.
That's cool. What's one thing that you've learned later in your life or later in your career that if you could go back and tell young Bill, and if he'd listen to you, it'd make a real positive impact on his life?
Oh, God. I guess one thing that I would say is that it's the importance to just keep on trying. Just stick with your vision and just do that, keep doing that. Not that I didn't, but that was very important to do that. You can do impossible things. It might seem like impossible at the time, and you can do them as long as you stick to it.
Said from the mouth of somebody who's done many impossible things. Bill, it has been a real pleasure having you on. And as I said before, pleasure having you in Connecticut, and best of luck in this important work.
Thank you. It's been a pleasure being here. Thank you.
Made in America with Ari Santiago is brought to you by CompassMSP.
Thanks for listening and spending some time with me today. My goal is to help build a strong manufacturing community, and it would be impossible to do without all of you.